Hold up.
Hello all, welcome to Math and Toss. So today our topic is coordinate geometry. So coordinate geometry is one of the branches of geometry where the position of a point is defined using the coordinates. It helps us to study geometry using algebra and understand algebra with the help of geometry. And because of this, it has been widely used in the field of physics, engineering, navigation, seismology, and even in art. So today in our section, we'll be dealing with section formula, where to use and how it is being utilized. Let's get started. So to draw a line segment, we need 2 points. So we here consider A, x1, y1 and B, x2, y2. And suppose take a point P. So generally consider its coordinate as x and y, and it divides AB in the ratio 1:1. So what does that ratio tells us? It tells us that the line segment AB is divided equally into 2 halves by the point B. So that's what the ratio 1:1 gives us the information. What happens if some other ratio is given to us? For example, say 4:1. So in that case, the line segment AB is actually divided into 5 equal parts, of which P will lie in its fourth part. So that is what 4:1 ratio tells us. Now let's take another case, 2:3. In this case, the point P is shifted little towards your left. So again here, 2:3 means 2 plus 3, that is total. There are 5 equal parts into which the line segment AB is divided, and the point P will lie in its second part. So that's what the ratio actually tells us. Now, what happens if the ratio is generally considered? So let's take the general representation of ratio as m1:m2. Now, in that case, or how are we going to apply section formula, or what does actually section formula tells us? So section formula is being used to find the coordinates of the point that divides the given line segment in a given ratio. So here the endpoints is A and B with its coordinates x1, y1 and x2, y2, and in a particular ratio m1:m2. So the point P is dividing the line segment in the ratio m1:m2. So I need to find the coordinates of P. So section formula helps us to find it out. That is m1x2 plus m2x1 by m1 plus m2, which gives the x coordinate of the point P, and m1y2 plus m2y1 by m1 plus m2 gives you the y coordinate of P. So section formula helps us to find the coordinate of P that is dividing the line segment in a given ratio. Let's look into a question. Find the coordinates of the point P which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3:1 internally. So what does the term internally means? Internally means the point P will lie inside the line segment. If they said externally, it means the point P lies outside the line segment. Now in this section we are completely dealing with internal cases. Okay, so the endpoints are given to you 4, -3 and 8, 5, and the ratio 3:1. So x1, y1, x2, y2 and m1:m2. So 4 becomes your x1, y1 becomes your -3, x2 as 8, y2 as 5, and m1 as 3 and m2 as 1. Now we apply the section formula and substitute it with the values that is given to us. So always make sure that when you're writing the formula, don't mix up the suffixes. M1 will always go with x2 and y2, and m2 will always go with x1 and y1. So if we misplace the suffixes or if we multiply them differently, your answer will be completely wrong. So now that we are substituting in the formula, and simplifying we get the coordinates of the point B, that is 7 and 3. So 7 and 3 is a point that divides a line segment in the ratio 3:1 internally. Let's look into another case. Here again we have the line segment AB with coordinates of A as x1, y1 and B as x2, y2, and a point P is already given, and suppose that we don't know the ratio in which it is divided. So in that case, usually we take the ratio as m1 is to m2, which will be known to us. Suppose when it is unknown, we take m1 by m2 is to 1. That is, m1 by m2 is considered to a constant k. For making the problem a little more simpler and easier to calculate, we consider the ratio as what? K is to 1. So if we get the k value, suppose as 5 or 2. Suppose if it was 5, then the ratio will be 5 is to 1. If I got the k value as 2, it will be 2 is to 1. And if I get the k value as 2 by 5, that means 2 by 5 is to 1. That means 2 is to 5. So that's the reason that we have taken the k. Now let's see how the section formula changes when we substitute this k is to 1 instead of m1 is to m2. So kx2 plus x1 by k plus 1, ky2 plus y1 by k plus 1. Instead of m1 I take k, and instead of m2 I take 1. So let's look into a problem based on that. Find the ratio in which the y-axis divides the line segment joining the point 5, minus 6 and minus 1, minus 4. So the endpoints of the line segment is given. Now this line segment is being divided by another line segment, and the peculiarity of that line segment is that it is the y-axis. So they have asked us to find the point of intersection. So you can see here that they have asked the point of intersection as well as the ratio is also unknown to us here. Yeah, so this is a perfect application of the previous section that we had discussed. So let's see. We considered the ratio as k is to 1 because here the ratio is unknown. So first set of coordinate taken as x1, y1. Second set of coordinate is taken as x2, y2. And instead of m1 I substitute k, and instead of m2 I substitute 1. Now let's apply this into the section formula and let's see what happens. So kx2 plus x1 by k plus 1 will be your x coordinate of the point P, that is dividing a line segment, ky2 plus y1 by k plus 1. Now substituting your x1, x2 and y1, y2 values, this is the coordinate that you will be getting. Now that we are going to think a little bit more in this case. Now what is the extra data that was given to you? That is, the line segment was a y-axis. So you know that any point on y-axis, its x-coordinate will be what? 0. The general formula or general representation of points on the y-axis is such that 0, y. That means your abscissa will be 0, or your x-coordinate is considered as what? 0. So here in the given coordinates, who is your x-coordinate? Minus k plus 5 by k plus 1 is the x-coordinate. So that is equated to what? 0. So when simplified, your denominator is cross multiplied with 0, which will again give minus k plus 5 is equal to 0, and k becomes 5. So thus you got the value of k as 5. So the ratio is what? 5 is to 1, and I substitute k value in the point of intersection formula. You get the values as 0, minus 13 by 3. So 0, minus 13 by 3 is the point on the y-axis that is meeting our line segment joining the point 5, minus 6 and minus 1, minus 4 in the ratio 5 is to 1. So a last subdivision of the section formula again is that you have a line segment again AB with the coordinates x1, y1 and x2, y2, and a point P is exactly dividing AB in the ratio 1:1. In this case, what happens to our m1 is to m2. So instead of m1 I take 1, and instead of m2 also I take 1. So what will happen to the section formula? Section formula will get reduced as follows: 1x2 plus 1x1 by 1 plus 1, comma 1y2 plus 1y1 by 1 plus 1. So x2 plus x1 is again equal to x1 plus x2. So x1 plus x2 by 2, which is your x coordinate of point P, and y1 plus y2 by 2, which is the y coordinate of the point P. So this is the formula that is used for the cases where they say that it is divided equally, or they say that the ratio is 1:1, or it is bisected. You can find the coordinate directly like this. So this is the another part of section formula. Now you can try out more problems that has been shown in your description and try out these problems. Stay tuned for more. Thank you.